request the program coordinator, Dr. Ashish Maheshwari sir, to please welcome our today's speaker with a sapling. Thank you, sir. Yeah, one more formality. I would like to take pleasure of introducing our today's speaker, Dr. Rohit Bhakar, sir. Dr. Rohit Bhakar is a professor in Department of Electrical Engineering and Center for Energy and Environment. He leads the Power Management Research Group, which runs first of its kind MTech in India on power system management. He has a wide research experience on multiple aspects of power and energy, ranging from network pricing, electricity markets, risk management, and so on and so forth. He has supervised over 12 PhDs and 40 MTech dissertations and published over 200 papers in top-rated journals and conferences. His current research targets include net zero planning, local energy market designs, multi-energy systems, blockchain applications to energy systems, virtual energy storage and virtual power plants. He has held multiple research grants of over 10 crore rupees from Indian and international funding agencies and industry. He has over 24 years of experience in teaching, including that of electrical engineering at undergraduate level and power system engineering and energy and environment engineering at postgraduate level. He has served coordinator, Indian Institute of Information Technology, Kota, Center for Energy and Environment as its head, IEEE Rajasthan subsection as its chairperson and vice chairman, IEEE PES Working Group on Distribution Network Charging and Tariff Structure as its secretary. He has been a serving member of State Advisory Committee, Rajasthan Electricity Regulatory Commission. So such a multifaceted profile. We are blessed to have you with us, sir. So without further ado, I would like to request our today's speaker, Dr. Rohit Bhakar, sir, to please take over the charge. Thank you, sir.
I'll have to come closer to you. So, thank you, organizers. Please have a seat. Thank you very much for inviting me. I've been told that this is a faculty development program and we intend to learn new things which possibly we have not been taught in our undergraduate programs. And since we have been teaching in, I guess all of you are teaching in polytechnic colleges? Engineering. Some engineering, okay, all of you are teaching in engineering college. So there are always, technology is something that is never static. It keeps on evolving. What we studied in our undergraduate days or postgraduate days, those things have become obsolete over a period of time. New things keep on coming. If we do not keep ourselves abreast with what new changes are happening, it is quite likely that it is not history or science that remains static. What was invented 50 years ago, 100 years ago, that it is not that it doesn't remain true, but it is not relevant. Engineering and technology, until and unless we teach what is the latest, it is just not relevant. Also, I've been told that we have got some of you coming from the electrical background, some from mechanical background, and some from IT background. Civil as well. So, what is the common thing that connects all engineering domains? Some E, is it engineering?
Eagerness to learn new things.
Yesterday I was teaching in my undergraduate class. I think all of what we do in engineering, whether you come from civil, electrical, mechanical, all of us, everything boils down to money. Eventually it is the economics which drives all engineering systems. whatever we do, whether you are trying to develop new engineering designs, it is all about optimal designs. They should be economic, and obviously they should be efficient. Same is the case for electrical systems, same the case for IT systems, same for chemical engineering as well. So whatever we are doing, if it is not economically viable, if it is not economically valuable, we would not be incentivized to do that part. And eventually technology and innovations are driven by economics only. Wherever you come up with an invention, you come up with a patent, and if nobody uses it, it is waste. Your invention, your innovations are waste. So until unless there is an economic value to what you are doing, all our engineering is of no use. But what we teach in our courses is pure engineering. So eventually we have to evolve ourselves and see what new things are happening in the industry, what new things are happening in the sector which would drive innovations in the future. Which are those issues where we need to put an effort, even if we want to develop a patent, or if we want to do research, or if we want to design something new, what is that domain in which we should be working? So I'll try to keep it as general as possible so that people from all domains they can understand. Take the case of drones. A few years ago, people thought that it is just an invention, but there is a significant economic value to it. And not only economic value, there are a lot of strategic values to it. So the evolution in the drone technology over the last 5 years has happened like anything. And that makes a very big business proposition. A lot of people are making so much of money in that. Similar to that, I'll be focusing on power sector. What is happening in the electricity sector as such. It is not specific for people coming from electrical background. It touches upon all set of people, those who come from mechanical, those who come from civil as well. We do a lot of research on buildings, the energy consumption in buildings, and that makes a very interesting facet. I think I'll be able to touch upon that in some of these slides as well. Just to give you a very broad glimpse, India is a large power consumer. The peak demand in this country is somewhere around 430 gigawatts. That is a huge number as of now. The whole of the Indian grid is interconnected in the sense that whether you are staying in Daman, whether you are staying in Rajasthan, whether you are staying in Assam, the electricity that you get from the grid in itself is interconnected. So all consumers who are connected to the grid, they are connected to the same grid, what we call as the national grid. Earlier, few years ago, we used to have the northern grid separate, the southern grid separate, the eastern grid separate, and so on. We used to have 5 grids, but over the last decade, they all have integrated, and now we have got a single grid in which whatever power is getting injected in Rajasthan, whatever power is getting injected in the northeast through the hydropower plants, whatever power is getting injected from the wind generators of Tamil Nadu, they inject it into the same grid, and people like us consume electricity in different forms. A big challenge in the grid is, though I hope everybody understands what grid is. Those from civil also, they would easily understand what grid is. One big challenge in the grid is that the demand that we have, it is not constant. It varies. It varies as per our uses that we use. for a residential customer, he may like to use electricity during the evening hours. 5 o'clock he reaches his home, switches on the lights. Lighting drives a significant portion of your residential, the demand of the residential consumers. And he goes off to sleep by possibly by 11 o'clock, so he switches off the light. If he is using an air conditioner or a cooler, possibly the demand still survives. Or for those people who are living in cold places, possibly during the morning hours they'll switch on their geysers, so that peaky demand occurs in the morning hours. Those from the offices, they have the demand coming up at around 9:30 or 10 o'clock. जब हम office खोलते हैं तो the demand comes up. You start using air conditioners. So they have a relatively flat profile during the day, and during the evening hours, 5 o'clock, 6 o'clock, when the offices close, the demand goes down. For the industrial consumers, if the industry is opening up at 9 o'clock, the demand comes up, closes shop at around 5 or 6 o'clock, the demand goes off. It would have a typical flat profile during the course of the day. Commercial establishments like shops, they have got their own different timings, and depending upon the timings, they would have their own demand profile. None of these consumers or the class of consumers as residential consumers, commercial consumers, or industrial consumers, none of the demand portion is controllable. You will switch on when you like it, you will switch on when you like it, you will switch on when you like it. So, in essential, in the whole of the grid that you see, based upon when you want to use electricity, the demand varies. The demand is essentially not controllable. In any electricity grid, to maintain this constant illumination or a flicker-free illumination, you need to have a quality power supply. In the sense, what is the voltage of power supply? 230. So the voltage that should be supplied, that should be 230 volts. This we all understand. So if the voltage is not 230 volts, there would be some flicker. If there is a frequency is not 50 hertz, there would be some flicker. So at all points of time in the system, in the grid, if the demand in the grid is not balanced by the supply in the grid, it is quite likely that there would be voltage fluctuations or frequency fluctuations. To maintain the grid in a stable way, at each and every point of time, you need to maintain balance between the supply and the demand. This is essential, which all electrical engineers have studied, possibly supply demand balancing, system operation. I guess most of you are comfortable with what, including the civil engineers. Are you able to understand what I am teaching?
Yes.
कि क्या करना होगा? If you want to operate the grid, you have to operate the grid in a balanced way, that whatever is the demand. Why this problem comes in? Because electricity cannot be stored in a big way. अगर आप electricity को store कर पाते, तब तो आप कभी भी जब डिमांड बढ़ी आपने स्टोरेज से सप्लाई कर दिया, जब एक्सेस जनरेशन अवेलेबल हुआ आपने स्टोरेज से उसको स्टोर कर लिया. दैट इज नॉट द केस. Because that is not the case, you cannot store electricity in large quantities. The only options that are available from some of the chemical engineers they'll appreciate are small battery storage options, limited options, or hydropower plants. They have got storage facilities available, but again, there are the limitations of how much you can operate those power plants. Because of these challenges, at all points of time in the system, whatever is the generation and equivalent, whatever is the demand and equivalent level of generation has to be made available. So we call it the real-time balancing of the grid, that the demand and supply has to be balanced at each and every second. Unfortunately, in Indian grid, till 2016, we were facing significant peak shortages. If the demand was 380 gigawatt, the maximum that we could generate at any given point of time was somewhere around 370 gigawatt. When the demand went to 400 gigawatt, our maximum that we could generate, whenever the peak would come in either two forms. Either it comes up in, when does it come up? Summer?
Evening time.
No, which is the season in which the peak demand comes up?
Summer.
Should I use a mic or? आपको आवाज आ रही है ना last time?
Summer.
कब आती है peak demand इंडिया में?
In India, summer, sir. Whereas in Western, it's in winter. Where more cold weather is there, they use heaters, room heaters. In foreign countries, at that time in winter they will get the peak demand. Whereas in India, in summer we will get peak demand.
Few years ago, we used to have the peak demand during the winter time. The reason was no. The reason was these pumps, agricultural pumps. Those paddy fields, they were pumping water like anything. So the peak demand would come up during the winter time. The pumping demand was significant. And this agricultural demand was driving the national peak. It is only over the last few years that we have become affluent. We have started using air conditioners. And the cooling demand in this country has significantly risen, because of which the peak demand is now coming up in the summertime. Essentially, we have got two peaks. One during the summertime because of the cooling demand, and the second one because of the demand due to the agricultural pumps. It is quite likely that the demand due to the agricultural pumps will not drive the peak demand in this country in the future. Various reasons. Agriculture, people are less dependent upon agriculture. Now there is a scheme called Kusum, where they put up those solar panels at the very place where they are having a pumping load. So whatever new pumping load is coming up, that is being supplied by those solar panels. So there is a likelihood that whatever local demand is there, that is being fulfilled by those solar panels. So a significant portion of that local pumping demand is being fed by the solar panels that are being installed at the local level in those fields. Still, we are facing challenges with supplying the peak demand in the system. It is not that we don't have the capacity. We have got large power plants, and the installed capacity is much higher than the peak demand in the system. It is much higher. However, all power plants, they do not operate during the peak time. Many of them are under maintenance, many of them do not have the required fuel. We have got a large number of gas power plants in this country, but we don't operate them. Because the time when we installed those gas power plants, the gas was cheap. Now the gas is costly. If you start producing electricity using gas power plant, the cost of electricity production is coming somewhere around 40 rupees per unit. Not viable. So we don't use gas power plants. So the capacity, installed capacity, we have got significantly high installed capacities available. Hydropower plants, we don't use those hydropower plants at all points of time because water is not available at all points of time, or we do not have sufficient storage capacities available. So that reduces the capacity of the grid to supply the peak demand when the demand exists. We have got limited flexibility on the generation side. Coal power plants many times the coal is not available. Shortages, if you see last several years, coal supply shortages is something that is impacting the industry because a large number of power plants they do not have that coal available. Coal mining is becoming difficult. Licensing in forest area for coal is becoming difficult. That is a challenge. Nuclear power plants, during about 15 years ago when we started with this US-India nuclear agreement, we thought nuclear power plants would come up in a very big way. That did not happen. There is resistance coming from several quarters. Investment is not coming up in a way that it should come. So there are challenges in coming up, bringing nuclear power plants. What is happening is, what is coming up? Renewables. A lot of wind turbines and to that extent, a lot of solar panels, they are getting installed. A large number of solar farms are getting installed in this country to fulfill the demand, ever increasing demand in the system. So the generation portfolio in the sense कि किस तरीके के plant हैं जो power supply कर रहे हैं, that generation portfolio is changing. Earlier it was dominantly thermal or coal-based power plants, and including hydro. That was what we have studied, that India produces electricity primarily from coal power plants and hydro power plants. However, nuclear came up in between. It is few facets, few power plants of nuclear, few nuclear power plants, they are in pipeline. Renewables, initially wind came up as a promising technology. Large number of wind power plants, they came up in Tamil Nadu, they came up in Gujarat, to Tamil Nadu, Andhra, Gujarat, 3 states. To a certain extent Rajasthan also, not a very big player in wind generation. However, when solar came up, if you remember the story of some 20 years ago, it was costing somewhere around 70 rupees per unit. Somewhere around 17 rupees per unit was the cost about 2 decades ago. The technology, the point that I wanted to drive was because of the innovation in our kitchen, we have over a period of time we have started using more and more electrical gadgets in our kitchen as well. So our dependence upon the form of energy that we are using, it is shifting from the conventional. हमने कभी कोयले से भी तो सीढ़ी जलाई है ना, हाँ, लकड़ी भी यूज करी है. So earlier we were using that. We shifted over to clean gas. Now we are shifting over to electrical gadgets like oven, like induction cookers. Over a period of time, and you will see this transition happening very fast. Once the cost of, how many of us had heard the word induction cooker? आज से 5 साल पहले. अब सबके घर में आ रहा है. So the impact, once the technology has matured, the impact that it has on our uses and the impact that it has on the grid is significant. आज से 5 साल पहले हम इंडक्शन कुकर यूज नहीं कर रहे थे. धीरे धीरे करके when everybody wants to be comfortable, nobody wants to use gas, people will shift more and more towards electrical appliances. So this energy transition is happening in which our usage is shifting from traditional sources of energy to electrical sources of energy. Our transportation is shifting from कोयले के इंजन का ट्रेन चलाते थे, फिर हम डीजल पे आ गए, Now 100% of the network is electrified. 100% of the electricity network in this country is electrified. And this is, हमें किसी को खबर आई नहीं. It has happened over the last 4-5 years. So the whole of the transportation sector as such now got electric buses, electric cars, electric scooters, everything is getting electric. There is a significant change in the transportation sector, which was a significant user of chemical energy. Significant change is likely to happen in the kitchens. The uses of gas, it is not that the uses will go down, no. The additional uses that would have happened, that is now getting substituted by electrical energy. हाँ, पहले हम जब खाना बनाना होता था तब खाना खाना होता था तब खाना बनाया जाता था. अब हम खाना बना के रखते हैं, उसको 4 बार गर्म करके खा लेते हैं. We are using ovens, so microwave oven and all this stuff we are using. We prepare it once and boil, heat it up multiple times and use it. So the quantum of energy that we are using, that is significantly increasing. We are reducing our manual effort, but we are enhancing the uses of electrical energy as such. This is what we call one segment of energy transition that is happening in our day-to-day lives, which we possibly usually do not observe, but this is the thing that is making an impact on the grid, on how we are using it, when we are using it. That drives. अगर प्रधानमंत्री मोदी आए और कहें कि नहीं आज सबको राम रसोड़ा बनाना है, let us go into the kitchen and prepare some food. Everybody goes to the kitchen, everybody prepares food. What will happen? The electrical load because of the kitchen, that will significantly increase. This may seem to be a surprise, but this was what exactly happened on 9th April. I think it was 9th April, COVID time, when we were clapping, when we switched off our lights. We did it. Similar things can happen. It is not about instant specific events, but these are likely changes that are going to happen, that our demand is significantly shifting. I hope I'm not wrong. We are changing. So this impacts our system in such a way that our demand will continue to increase. Despite whatever power plants you continue to put up, your demand will continue to increase. Because our electricity consumption pattern and our electricity consumption will continue to increase. We are shifting, we are going in for an energy transition. Because we deem electricity as a much efficient and a cleaner fuel. I hope people from chemical and civil are all able to understand. Yes. I'm not teaching anything which is not easy to, which is difficult to understand. This is just a reflection of what the demand is. Industrial, different customer classes, industrial, domestic, traction demand, agriculture demand, commercial demand. This is a typical portfolio of demand that exists in this country as of now. Depending upon where the energy transition is happening, that sector will start making an impact on the overall grid. कि वो deficit कब आएगी? क्या वो सर्दियों में आएगी, गर्मी में आएगी, या जिस दिन हम राम रसोड़ा बनाने जाएंगे उस दिन आएगी? It all impacts. Those things which seem simple on that night when we were switching off the light, had the grid operator not been careful, we would have faced a blackout. Those from electrical can possibly understand. Because the quantum of ramping that happened in the grid within 10 minutes or half an hour was 32 gigawatts. Massive as compared to the total capacity of the grid, which was at that point somewhere around 400 gigawatts. तो अगर 400 गीगावाट का ग्रिड है, आपने आधे घंटे के अंदर 32 गीगावाट, it came up like that. The quantum of instability that it brings in the grid is significant. It is unmanageable. Why I'm pointing to those issues? Because they are now relevant for the industry. They are now relevant for operating the grid. What changes are happening in the grid? How many of us pay electricity bills? How many of us were paying electricity bills some 20 years ago? Some of us were not paying. है ना? Some were directly putting up some of us. How many of us have meters installed at our households? Meter. How many of us have got smart meters installed at our households? Smart meters, है ना? कुछ घरों में लग गए. We are standing in 2024. By the end of 2025, each and every household will have a smart meter. That is the transition that is happening. That is a digital transition that is happening in the grid. And this smart meter measures your energy consumption at every 15-minute interval. कि आप हर 15 मिनट पे आपने कितना पावर कंज्यूम किया, उसका वो रिकॉर्ड करेगा. आपसे पूछेगा नहीं, but it will relay using some technology, some GSM or some RF technology to the utility, to the supplier. The meter reader will not come after 2 months to read the meter reading. At the very instant, the signal is getting picked up. Every 15 minutes, the information is getting picked up. It is getting relayed to the utility. This is the level of transition that is happening. That each one of us are getting connected to the grid in a real-time fashion, and the information about our consumption is getting relayed to the utility in every 15 minutes cycle. So we call it the digitization of the grid. It is becoming more and more digital. So it creates ample opportunities for those who come from, possibly from IT. Some of you are from IT branches, I guess. It creates immense opportunities for those who come from IT branches or computer science branches or communication technologies, those who understand communication, as to what sort of communication technologies are to be adopted, how that data is to be accessed, how that data is to be analyzed. Not many things, but having a pure computer science degree may not be helpful because there is a lot of electrical engineering involved in that. The domain knowledge is important for anybody to understand the value of that data, or the value of those numbers that are getting picked up. So we are getting more and more connected, more and more digitized. Smart meters, grids are becoming smarter. All substations, they are getting digitally connected. All that information, every substation has now got a digital meter. That information is getting relayed at multiple levels in the grid. So everybody in the system, those who are operating the grid, they are aware of what is happening in this area, what is happening in this area, what is happening in this area, because in a real-time fashion, they have got all the information available. In a real-time fashion. Every 15 minutes, they know कि इस locality में इस transformer में कितना load है, इस transformer में कितना load है. Forget about transformers, they know कि हर customer का हर 15 मिनट में कितना load है. They know this much of the data, granular data is available with them. That creates immense opportunities for people from different domains to bring value on how the system and how the grid is to be operated. It is becoming more and more distributed. पहले पावर कहाँ से आती थी? थर्मल पावर. We used to say grid से पावर आती है. अब मेरी छत से आ रही है. I put up a solar panel on my rooftop. A large number of us would have done it. होंगे कुछ के घरों में तो होंगे. So what we have done is, rather than securing power from the centralized power stations, now we are securing the same power from our rooftops. It is becoming more and more distributed. The generation, rather than being concentrated in large power plants, it is now getting distributed into the grid. That changes the very nature of how the grid is to be operated. In my university where I teach, we have put up 1 megawatt of solar panels. When does the peak demand come? कब आती है peak demand? No, it doesn't come during that time, because during at 2 o'clock, when all of us are using air conditioners full during summer time. ठीक है? The solar panels, they are producing the maximum. We get a dip in the grid. We get a dip in the demand. So that is a time where we have got a low demand in the system in our university. Why? Because we are producing at that point of time. And that is true. I can show you the graphs. The peak comes after 5 o'clock, 5 to 6 to 7, where two things. Those who are workaholics, those who stay in the office, they continue to use ACs. Those who go back home, they feel गर्मी है, घर पे जाके AC चलाते हैं, या घर पे जाके चाय बनाएं. You go to household, you start using more electrical appliances. That drives the grid demand. तो हमारी peak demand आती है शाम को 5, 6, 7. और दिन में 2-2:30 बजे we get a dip in the system. This is because of the distributed nature of generation technologies that we have adopted over a period of time. And this is likely to increase over a period of time. Sarkar subsidy दे रही है, we are putting more and more solar panels. It is likely to change, and this is because cheap generation is available. This is likely to change the way by which we produce, we use, and we store energy. So providing local energy to facilities, falling prices of renewable energy. पहले 17 में आती थी, अब 2 रुपए 3 रुपए में produce solar generation. More electric systems. To make the systems decarbonized, we have done away with diesel locos. We have done away with. We don't allow diesel buses to enter enter Delhi. So more and more electric buses, more and more electric cars, electric vehicles are coming up, and more efficiency. This is another important facet which possibly each one of us has touched. आज से 7-8 साल पहले एक टाइम आया था जब सरकार ने कहा था कि आपके पास वो जो पुराने वाले जो आओ और बदल के ले जाओ. कितने रुपए? 100 रुपए में giving a CFL. Do we have a CFL installed here? No. Why? CFL कब आया और कब चला गया, क्या हमें पता चला? चला? नहीं पता चला. जैसा CFL दिखता था वैसा ही LED दिखता है. हमें पता ही नहीं चला कि कब हमने इनकैंडेसेंट बल्ब को छोड़ के, जब हमने इनकैंडेसेंट बल्ब छोड़ा तो हमें पता चला. क्यों? क्योंकि हम वहां दुकान पे गए और हमने उसको बल्ब को चेंज किया. एक बार हमें पता चला कि हाँ कुछ बदलाव हुआ है. Some things changed. We paid 100 rupees for that. But when we changed from CFL to these LED bulbs, we didn't realize the technology changed so fast, and the cost of a LED bulb was so low कि आपको चेंज करने की जरूरत नहीं पड़ी. आप गए बाजार में, दुकानदार ने कहा भाई साहब मैं CFL के बल्ब बेचना बंद कर दिया. This is the answer that you get. Because with the same cost and a very efficient bulb, कितने वॉट का बल्ब आता है LED बल्ब? 5, 15, 9 वॉट, 11 वॉट, 13 वॉट. ठीक है? पहले वो बल्ब कितने वॉट का आता था? 60 वॉट, 40 वॉट और 100 वॉट. ठीक है, 200 watt. Now imagine if you are using an LED bulb with a 200 watt, what is the quantum of illumination that you will be creating? So for creating the same level of illumination, you require a very low energy consumption. So the devices that we are using over a period of time, they have become more and more efficient. This is a thing that we saw in our lives, but we didn't focus upon that. These are the changes that are likely to happen. These and similar changes are likely to happen on our side. Possibly, जब हम बाजार जाते हैं तो हमें लगता है कि बेटा इलेक्ट्रिक स्कूटर ही खरीदना है, या इवन आई एम वेटिंग कि मेरे पास डीजल कार है, आई एम थिंकिंग कि अगली कार खरीदूंगा तो मैं इलेक्ट्रिक कार खरीदूंगा. दिस इज द टाइप ऑफ consumer behavior that has started changing. This drives the change in the grid. Now we don't feel bad कि अगर हमारा वो LED बल्ब ऑन भी रह गया तो रात को ठीक है. पहले हमें वहाँ पर लिखना पड़ता था कि ऑफिस बंद करें तो आप स्विच ऑफ करें. Now it doesn't make a difference. The quantum of energy consumption is too low कि कॉरिडोर में अगर लाइट जल रही है तो it doesn't make much of an impact, though we do say कि save electricity. However, we have started realizing that even if you switch them off or on, if you keep them on, the quantum of energy consumption that would happen in the night time in the corridor would not be significant. Now what happens? These type of innovations and changes in our lifestyles will drive the way by which we use energy over a period of time. There are now two facets of this electricity supply system. One is the generation side, one is the consumption side. Changes are happening on both the sides. And connecting these two is the transmission system. For those who come from those who do not come from electrical energy, possibly I'll just brief them that we produce electricity at somewhere around 11 kV or 13.5 kV volt. That is the normal generation voltage at which we generate. We, in order to transport that electricity to the consumers, we step it up using transformers to very high voltages, so that the losses in the system, I square R losses, they go down. At the consumer side, we use step down transformers, get it down to 230 volts, which is our consumption, either 230 volts, or if we are industrial consumers, possibly at 11 kV. If our drives are operating at 11 kV, and either 230 volts or 11 kV, we are using that electricity for most of the purposes in the system. The nature of the transmission system, though it has changed, but it has not changed significantly, except for the case that it is becoming more and more controllable, more and more digitized, more and more observable. We have put in large number of meters, we have put in PMUs, we have put in n number of devices in the grid by which we can observe what is the quantum of power flowing in each and every network. Minutely, we can observe that in microseconds. Well, if you have heard of PMUs, phasor measurement units, which are installed in the grid, they measure the power consumption every microsecond, every few microseconds. So that is the level of observability that exists in the grid. On the generation side, the changes are happening. On the distribution side, on the consumer side, the changes are happening. This is what is driving our electricity world. I hope whatever I have discussed is easy to understand.
Yes, sir.
Yes, sir.
Nothing that makes you sleep, except for those who are sitting on the last benches. Is it too boring? There are a couple of students who are sleeping. With this background, हमारी डिमांड तो शाम को 5:30 बजे पीक कर रही है, सोलर दिन में 2:30 बजे प्रोड्यूस कर रहा है. नॉट अ वेरी कंफर्टेबल सिचुएशन. कब प्रोड्यूस करना चाहिए? शाम को 5 बजे प्रोड्यूस करना चाहिए, जब हमारी डिमांड बढ़ रही है. वो नहीं पा रहा. Because of the change in the generation portfolio, earlier we were generating using large power plants, thermal power plants, hydropower plants, which were controllable to a significant extent. हमें जब डिमांड बढ़ी हमने पावर जनरेशन बढ़ा दिया, जब डिमांड घटी हमने जनरेशन घटा दिया. We could balance the demand and supply because the power plant operator कि उतना कम फ्यूल डालेगा, उतना कम जनरेट करेगा. It was a comfortable situation. We were sourcing our energy from large power plants, which were controllable. Hydropower plants, which were controllable. Now that rooftop, it is not controllable. It produces when the sun is there. The wind turbines, they produce when the wind blows. It is not in our hand. And you cannot store that. So the challenge that is coming up in the grid is that if presently we have about 1,000 power plants connected to the grid in the Indian grid, out of those 1,000 power plants, earlier 990 were controllable power plants. So what we could do? जैसे डिमांड बढ़ी हमने बढ़ा दिया, घटा दिया, everything was working fine. Now, out of those 1,000 power plants, 800 are controllable, 200 are renewables. They are just not controllable. They'll produce when they want to produce. Just simply not controllable. Wind will blow when it will blow. It is even difficult to predict when wind will blow. Solar, at least we know कि ठीक है दिन में धूप आएगी, generation बढ़ेगा. The challenge is earlier all the demand components, they were uncontrollable. All the demand were uncontrollable. मेरी मर्जी आएगी तभी तो मैं स्विच ऑन कर रहा हूँ. Everything was uncontrollable. The system operator could not control it. All generation would follow the demand. जैसे डिमांड बढ़ी आपने जनरेशन बढ़ाया. Now, so we have 50-50 balance कि 50% पैरामीटर आपके अनकंट्रोलेबल थे, 50% पैरामीटर आपके कंट्रोलेबल थे सिस्टम के अंदर बैलेंस करने के लिए. Now, out of those 1,000, 200 are renewables. So, only effectively 50% of demand was anyways uncontrollable. Out of this, 20% of the generation also has become uncontrollable. 5 years down the line, this 20% will become 40%. As a system operator, as a person who operates the grid, the challenge is पहले मेरा आधे लोग अनकंट्रोलेबल थे, अब आधे तो थे ही थे, बाकी जो बचे उसमें से भी 40% जनता अनकंट्रोलेबल है. Demand is increasing. Who is now responsible for following the uncontrollable demand and the uncontrollable generation? Who? The rest of those 40% were left. They are the only controllable devices in the system. So the pressure on those 40%, those 60% left, out of the 1,000 generators, those 600 generators left, those who are conventional generators, the pressure on them to follow what the demand is and what the rest of the generation is immense. It is immense. Because now 50 plus 20, 70% of the parameters in the system are uncontrollable. And you have to control and you have to balance the variability of those 70% components in the system by only 30% of what is controllable in the system. तो उस बेचारे जो 30% जो पीछे बच गया है उसका सारा जोर उसको बैलेंस करने में लग रहा है. This is the level of challenge that is coming up in the grid. And as per my understanding, this is the biggest challenge that is coming up in the grid. बहुत बार ये सवाल पूछा जाता है, ज्ञानी लोग बता देते हैं कि सोलर क्यों नहीं लगा लेते? Keep on putting up more and more solar. But even at the topmost policy level, when you ask them and when they ask us कि भैया कितना सोलर लगा सकते हैं, a layman will say कि ठीक है सारा सोलर कर दो, why use coal power plants, why use other sources of power plants? But is that possible? No. I hope now you have understood the problem. That it is solar सस्ता हो गया इसका मतलब ये नहीं कि हमने चारों तरफ सोलर लगा लेंगे and will be able to handle the situation. No, because the variability and imbalance that it creates in the grid, it is just not possible to handle that. Just not possible. And this is a serious and a very serious challenge that is not come up, that will come up in the future in the next few years. Next 4-5 years, this challenge will come. Because solar को तो दिन में 2 बजे ही produce करना है, and we do not have the capacities to store all that power during the daytime. We don't have those. Partly it is mitigated by the cooling demand that exists, but no, that is not full demand. There are large number of other demands that exist which are not getting compensated with the generation type that we are using. So instead of those who are into electrical engineering, those who understand a bit of forecasting, पहले हम क्या करते थे? पहले हम डिमांड फोरकास्ट करते थे, आज भी करते हैं. जनरेशन फोरकास्ट करने वाले लोग भी एग्जिस्ट करते हैं. But now there is a new stream of people who explore net load forecast. The difference between what is controllable and what is uncontrollable, that is to be forecasted, because now 70% of the parameters are uncontrollable. Need to forecast not only this demand but this generation as well, and effectively you need to understand what would be the pressure on the remaining 60% generators that are left in the grid. So a new stream of research like net load forecasting, the remaining demand that exists in the system, that needs to be forecasted. Forecasting is one, but we need to find out the solution to this very, very big problem that is coming up. Solar लगाना आसान है, सस्ता है, but to mitigate the challenges, we need to find out solutions. Solutions could be from people from chemical side, those who say कि battery लगा ली जाए, fine, put up battery storage, that could be one of the solutions. What are the challenges? Cost, yes, cost is huge. If you put up battery storage, the cost is huge. Life is another issue. 7 साल बाद the battery is gone. The effective cost of putting up battery storage is significantly high as compared to putting up a power plant. The per unit cost. मैं power plant लगाऊं या battery storage लगाऊं, power plant आज भी सस्ता पड़ता है. So battery storage is not a viable solution. As of now, it is not an economically viable solution. What are the other solutions then? How do you solve this problem? How? ये बदलने वाले थे ही नहीं. They were natural कि ठीक है मुझे जब मर्जी आएगी तभी मैं बिजली यूज करूंगा. कुछ और जो कंट्रोलेबल थे वो ऐसे हो गए हैं जो will produce as per what is available. The pressure is on the rest of the generators. How do you solve this problem? You cannot control generation. The only solution left with the system is ask them to control as per what is available. Which, this is a thing that people have been talking about for the last 60, 70, 80 years. But this has never been successful. Asking कि भाई साहब बिजली पैदा हो रही है अब आप AC use करें, not possible. भाई साहब कहेंगे why? Not possible. I am not comfortable. है ना? भाई साहब शाम को 5 बजे बिजली पैदा नहीं हो रही है आप अपना AC off कर दें. No, भाई साहब won't do it. He feels I need to use AC. How do you encourage and how do you establish systems by which we bring in those people to respond? The whole challenge of, because we cannot play with the generation, the whole challenge will now focus upon a very big problem, what we call as demand side management.
Charges as per consumption, time of consumption.
Charges as per consumption,
Using rating appliance.
Time
Hmm?
of consumption.
Using rating appliances.
using
A 5-star rating appliance.
5-star rating appliances.
Consume.
Yes, 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 yes. How does all this thing come down? How does all this thing happen on the ground? It is not कि मैंने charging as per consumption. It was not easy. हुआ क्यों नहीं इतने साल अगर इतना easy अगर इतना solution था तो हुआ क्यों नहीं? Why didn't it happen? कौन सा?
Smart meter.
Exactly. The challenge was that when you were consuming electricity, वो बिजली मीटर रीडिंग करने वाले तो 2 महीने में एक बार आ रहा था. He didn't knew कि आप कब बिजली कंज्यूम कर रहे थे. He didn't knew. पर अब जो स्मार्ट मीटर लग रहा है, he knows when you are consuming electricity. Every 15 minutes he knows. He is able to observe when you are consuming electricity. So once अगर मुझे आपको कंट्रोल करना है, तो पहले कंट्रोल करने से पहले I should be able to observe you. When I am able to observe you, then only can I control you. So to control you, I need to have those devices, I need to have those systems, I need to have those technologies by which I can control, I can observe and control. So in that spectrum, application of digital technologies like smart meters, that brings value. Technologies which help us in communicating from the consumers, grid, to the generators, कौन सा solar panel कितना produce कर रहा है, getting that information every अगर हर second नहीं, every 15 minutes interval, that's important. Getting that information, being able to process that information, and that is one part of the problem. That is a technology solution that we are able to provide. That yes, we are able to observe when anybody is consuming or when anybody is producing. One part of the problem. Second is about economics. कि भैया शाम को 5 से 6 बजे अगर आपने एसी चलाया तो 7 रुपए की बजाय आपको 14 रुपए देने पड़ेंगे. Something of that sort. But those things can only be done once you know कि भाई साहब ने शाम को 5 से लेकर शाम को 8 बजे तक एसी चलाया. So a technology layer in the whole system is required to create that, or technology or a communication layer is required to create that information, that who is consuming and who is producing and what is the information that is available in the system. Another interesting thing that possibly we missed जब मैं शाम आपको कहूँगा कि शाम को 5 से लेके रात को 8 बजे तक आप एसी ना चलाएं, 14 रुपये लगेंगे। हो सकता है आप अफोर्ड कर जाएंगे, कुछ लोग अफोर्ड नहीं करते, वो अपना एसी बंद कर देंगे। पर आपके पास तो एक इलेक्ट्रिक व्हीकल भी है, उसको भी चार्ज करना, आप उसको कब चार्ज करेंगे? जब जरूरत पड़े तभी। जब जरूरत पड़े तभी अगर आप करेंगे तो आपको 14 रुपये देने पड़ सकते हैं। So the beauty of the system is just a second. Sorry. So the benefit कि कब मैं इलेक्ट्रिक व्हीकल को चार्ज कर रहा हूँ, दैट ऑप्शन इज अवेलेबल विद मी। सुबह चार्ज करूँ, दोपहर में चार्ज करूँ, रात को चार्ज करूँ, ऑप्शन इज अवेलेबल। आई विल चार्ज इट व्हेन द टैरिफ इज लो or the sun is high. Obviously the tariff will be low when the sun is high. So why is this option coming up? There are two type of things. Two reasons. One, my uses of that electric vehicle is in my hand. The rest of the time it is free. I can charge it at any point of time because it has got storage available. So that gives me the flexibility to charge it whenever the electricity is cheap, whenever I want to charge it. That flexibility is there with me. One reason. कभी भी जब सस्ता होगा तब मैं बिजली खरीद के उसको चार्ज करके मैं स्टोर करके अपनी गाड़ी चला लूँगा. There are other things also. मैंने कहा शाम को 14 रुपये में बिजली मिल रही है. Obviously some of the things, अगर मुझे ढोकला बनाना है तो rather than preparing it from 5 to 8, I'll possibly prepare it at some other time. Any type of cooking I can possibly shift rather than doing कि 5 से 8 में ही बनाना है. I can do that part. There are those electrical devices, they are more user friendly. वॉशिंग मशीन जरूरी थोड़ी है कि मैं शाम को 5 से 8 के बीच में कपड़े धो. नॉट रिक्वायर्ड. आई कैन डू दैट इन द मॉर्निंग आवर्स. आई कैन डू दैट. आई कैन शेड्यूल दैट. ऑटोमेटेड वॉशिंग मशीन्स. यू डोंट नीड टू डू एनीथिंग. यू जस्ट नीड टू शेड्यूल. आप कहेंगे तो रात को 2 बजे लेके सुबह 5 बजे तक कपड़े धो के रख के छोड़ देगी. दे विल डू ऑल द थिंग्स. नाउ विद मोर एंड मोर ऑटोमेशन ऑन द कस्टमर साइड, it is possible that our actual presence for utilizing that electricity may not be required, and the device may be operated at a time when we want. So you can use a washing machine. You can just put your clothes. You can use a washing machine possibly at 12 o'clock in the night, 2 o'clock, anytime. That can be done. It will do it automatically. It will wash the clothes automatically. So that gives you the benefit of having a flexible demand. That is, the demand can be made rather than uncontrollable. It is flexible as per the availability of electricity or as per the tariff that is being charged for using that electricity. This change or this technology change can enable or help us to mitigate this problem of net balancing. that we shift the uses of those devices like electric vehicles, washing machines, and possibly other activities, cooking, possibly some of the cooking we can shift. कि जब peak demand होगी, we won't do cooking. If the tariff is designed accordingly, and the tariff can only be designed and implemented when we have got those smart meters installed. This is a broader thought process that is coming up that would possibly change the way by which we use electricity. Does it make sense? Is it acceptable? Will it work or not? Does it make sense? No? Challenges? हम कैसे बदलेंगे? मुझे तो शाम को 5 बजे एसी चलाना है. Will that be the situation, or people are likely to change?
Few will change. At least few will, not 100%, but at least some changes. Some balancing will occur because of this system. Not 100%.
Why?
Due to the time limitations, maybe they are not available at that.
A
Why?
country like India.
Why won't we change? Why?
Thought process.
Is it the issue of thought process? Why won't we change?
India basically countries of people, those are habitual of adjustments. So they will adjust accordingly.
Will we change or will we not change? That is the question. Will change
Yes, sir.
or no?
Will change.
होना पड़ेगा इज नॉट समथिंग कि उन्होंने कहा कि भी आपको ताली बजानी पड़ेगी, आप ताली बजाएंगे, ऐसा तो नहीं होगा.
माइंडसेट बना हुआ है.
इकोनॉमिक जहाँ पे आता है लोग एडजस्ट करते हैं.
Exactly. Wherever the economic comes in, the economics of uses comes in, you will change. The change is not happening. That it is not. We don't foresee कि change होगा. It is not an issue of mindset alone. Primarily, it is an issue of economics. आप बिजली का कितना बिल भरते हैं महीने? 2000. आप कितना कमाते हैं महीने में? 50,000. What is the typical percentage?
5%.
5%. या ज़्यादा परसेंटेज हम बिजली पे खर्च कर रहे हैं? What is the percentage of money that we are spending on electricity consumption? What is that percentage?
Between 5 to 10%, 5 to 7%.
2%? Whatever you are earning, the percentage of money or your budget that you are spending on electricity, if that is low, you will never be incentivized to change your consumption or what he said, mindset. You won't change. But if, why will you change? Will change because we are using more and more electricity. The percentage of consumption, energy consumption that we are doing, it is getting, very first thing that I told you, the percentage of energy consumption that we are doing in the form of electrical energy, that percentage is increasing. So if earlier, if I was using, for my overall energy consumption, if I was using 50% electricity, now that 90%, one part, the number of electrical devices that I am using, that is significantly increasing. So my electricity demand is likely to go up. So also, the percentage of money, the percentage of budget that you would be spending on electricity, that will go up. चाहे सरकार कितनी बिजली फ्री कर दे, it will go up. एंड सरकार हैज अ लिमिट कितनी बिजली फ्री करी. बिजली फ्री करी उन्होंने 200 यूनिट तक वालों की. तो भाई साहब एसी चला रहे हैं, तो 200 यूनिट में उनका मन नहीं भर रहा है. His consumption is not limited to 200 units. His consumption is increasing. So he'll slowly come out of that कि मुझे सरकार के 200 यूनिट के फ्री की जरूरत नहीं है. I want to live my life in a luxury. I think things are changing. कितने ऐसे लोग हैं हमने से जिन्होंने गैस सिलेंडर की सब्सिडी छोड़ दी? काफी लोगों ने छोड़ दी, है ना? छोड़ दी ना? Why? Felt we don't require that. क्या 300 रुपए के लिए सब्सिडी लेना? A large number of us has left that subsidy. A large number. I believe what the government is saying. है ना? पहले हर कोई गैस सिलेंडर की सब्सिडी ले रहा था. अब हम ले रहे हैं क्या? नहीं ले रहे हैं. डोंट फील कि ठीक है यार 300 रुपए के लिए लाइन लगाओ, कुछ करो, ये करो, वो करो. As we become more affluent, as we become more energy hungry, as we become more developed, our energy consumption will increase. Our bills will increase. Our percentage of budget that we are spending on electricity, that will increase. If you go to developed countries like Europe and US, the percentage is significantly high. Significantly high. आपके कुछ रिश्तेदार वहां भी होंगे. आप उनसे पूछिए कि आप अपने बजट का कितना परसेंटेज बिजली बिल में पे करते हैं. And you will realize that that percentage is significantly high. So when the percentage is significantly high, आज हमें पिंच नहीं कर रहा है क्योंकि जब मैं लाख रुपए कमा रहा हूँ तो मैं 2000 का बिल दे रहा हूँ. तो मैं लाख रुपए कमाऊंगा और मैं 10,000 का बिल दूंगा, उस दिन आई विल पिंच. दैट डे आई विल थिंक कि भैया मुझे एसी शाम को 5 से 8 चलाना है या नहीं चलाना है, या वॉशिंग मशीन में चला के शाम को 5 से 8 चलाऊं या नहीं चलाऊं. इट विल इम्पैक्ट. Eventually it is the economy, the economics that will drive the mindset change. बाकी तुम्हारा mindset change नहीं होगा. नॉर्मल आपका जो 2 व्हीलर आता है एक्टिवा वगैरह कितने का आता है? लाख रुपए. वो जो इलेक्ट्रिक व्हीकल अपने खरीदते हैं वो कितने का? 1.4. It is costlier. Still we are buying it. Why?
Running cost.
And there is a lot of subsidy available. है? सरकार ने सब्सिडी बंद कर दी है. Now
Still buying.
we'll still buy. Why?
Operational cost, long term.
Or there is another facet also. We have possibly accepted the fact कि EV is a better vehicle
That better.
than petrol. It has gone into our heads, in our mindset, that yes, electric vehicles are less polluting. So even if it doesn't make an economic sense, we have become habitual to that. I don't think we'll be buying petrol scooters. Even if the Sarkar does away with the subsidy, we'll continue to buy electric vehicles only. This will. अभी सरकार ने बंद कर दिया. I think they have closed down. है ना? Company dairy because the scheme is going to end. Will it impact the EV sales? Because we become habitual to that. One, the cost of EVs have gone down. One part, yes. Second, we have accepted the EV has now become reliable. It is शुरू में जो आते थे बकवास आ रहा था, है ना? They were failing. Now they have become a reliable vehicle, and obviously we have a mindset कि एक बार पैसा लग जाए बाद में खर्चा नहीं लगे, दैट इज अ चीपर थिंग। वी हैव दिस माइंडसेट। आपको याद हो आज से 10 साल पहले हम सब लोगों ने डीजल की कार खरीदी, 2 पैसे ज्यादा दे देंगे लेकिन डीजल सस्ता है, बाद में वो डीजल महंगा हो गया। सो वी डेवलप दैट माइंडसेट कि ठीक है एक बार पैसा लगाना है, अच्छी चीज लेंगे भाई, बाद में खर्चा नहीं आएगा। दैट वाज द माइंडसेट। सो सेम इज द माइंडसेट, विल बाय इलेक्ट्रिक व्हीकल्स, एक बार खर्चा लगाएंगे, अच्छा व्हीकल लेंगे। वो अच्छा है नहीं है वी डोंट नो, बट वी हैव डेवलप्ड दिस माइंडसेट दैट दिस इज अच्छा व्हीकल, विल बाय इलेक्ट्रिक व्हीकल्स। सो द परचेज ऑफ इलेक्ट्रिक व्हीकल्स विल कंटिन्यू टू इंक्रीज। जैसे चल रहा था वैसे चलेगा, कोई फर्क नहीं पड़ेगा सब्सिडी से। सरकार ने वो इलेक्ट्रिक व्हीकल आपके दिमाग में बैठा दिया कि आपको वही खरीदना। सेम इज द थिंग, जब बिजली का बिल बढ़ेगा कुछ टैरिफ डिजाइन ऐसा आएगा, आपको धीरे धीरे आपको यू गेट इनग्रेन्ड। ब्रिंगिंग इन डिमांड साइड flexibility is important, relevant, and this is what will happen, and this is what will drive innovations in the future. This will drive innovations in the future on how to design systems, how to design electrical systems, how to design electrical power consuming systems which are controllable to a significant extent. A large number of companies are putting in investment into those segments. कि वो जो devices हैं वो उस पावर कंजम्पशन को कंट्रोलेबल कैसे बना सकते हैं। So those who do research, as I was discussing, those who do research on the component side, how to change the devices, how to develop new devices using digital technologies, microprocessors, or communication technologies, IT, IoTs. How to use those things to change the way by which these devices can be operated. This will bring in new revolution into this segment on the distribution side. जैसे वो बल्ब चेंज हुआ, हमें पता नहीं चला, ये चेंज होगा, पता नहीं चलेगा। We'll come up with chargers, electric vehicle chargers, which will have a time setting. कि जब ग्रिड के अंदर बिजली महंगी मिल रही है, वो चार्जर चार्ज नहीं करेगी। जब सस्ती हो जाएगी, वो चार्जर अपने आप चार्ज करना शुरू कर देगा। So these type of innovations will drive the electricity consumption sector over the next decade. Because there are n type of devices that we are using. Every device has got its own characteristics. Every consumption, every consumer or every device has a different responding capability. किस डिमांड को आप शिफ्ट कर सकते हैं, किस डिमांड को आप शिफ्ट नहीं कर सकते हैं. A wide variety of options will come up in a way similar to the one that we saw in mobiles. इतने ऐप, इसका ऐप, उसका ऐप, उसका ऐप, उसका ऐप. Revolution. Now everything is coming to that. The same sort of revolution you can expect. आते हैं ना आजकल कि आप मैं फोन से घर में जाने से पहले अपना एसी ऑन कर दूंगा, ऑफ कर दूंगा. फैन भी आता है ना, कार भी आती है. Those things. So remotely operated, because of the communication technology, remotely operated devices and remotely operated electrical devices, those things will come up. That will help us in mitigating the challenge that we are looking forward to. This is all theory. So we have started talking about demand side management, managing the demand, because now we cannot manage the generation. This is uncontrollable. Sab chalega. Those who are left behind, they are forced. To handle those uncertainties of the demand. This whole mechanism we have started, we call it, पहले हम इसको अलग अलग नाम से बुलाते थे, we used to call it demand response. A broader term is demand side management, managing the demand. Policy makers, utilities, and all people in all stakeholders in the government, they have been talking about this for years and years, but it is not happening. हम respond नहीं कर रहे हैं, mindset का issue नहीं है. The issue was because we didn't have the technology, we didn't have the appropriate economic signal. मेरी चूल्हा नहीं लग रहा था शाम को 5 से 8 बजे. So I was using electricity. The day the smart meter is there, the day I start paying for electricity consumption, I'll start adopting those technologies. I think I need not go through the theory. Which is more interesting, this one or this one? This one. How long can you sustain me more? Huh? Once I break the flow, my flow will be improved. So this is about demand side management. This is the broad theory, the broad challenges that we see. There are definitions. The demand side management hota kya hai? I think I've been able to explain what demand side management is. Managing the demand. These demand variations can happen due to any reason. I mean, I was just posting, before coming to the class, I was just posting in one of the groups, कि 22 जनवरी को क्या होगा? That is a big question. कि 22 जनवरी को आप क्या करेंगे? आप मंदिर जाएंगे? दिया जलाएंगे? या लाइट जलाएंगे? या रसोड़ा बनाएंगे? What will you do? This is a big question. So, we do research on these aspects. We do research on issues like उस 9 अप्रैल को क्या हुआ था? We were working on it. कि भाई साहब आपने कहा कि ताली बजाओ बंद कर दो. How it will impact? If you don't do research in these segments, you'll be surprised to understand what happens. On that night, the system operator had predicted कि जो demand variation जो आएगा, तो 12 गीगावाट का आएगा, 11-12 गीगावाट का वेरिएशन आएगा, क्योंकि लोग लाइट ऑफ करेंगे. प्रधानमंत्री ने क्या कहा था? लाइट ऑफ कर दो. ठीक है, हम अनपढ़ थे उस दिन, हमें पता नहीं था, हम बाहर गए, अपना मेन स्विच ऑफ कर दिया. और हमसे भी बड़ा अनपढ़ एक सब स्टेशन पे वो बैठा था, उसको लगा कि प्रधानमंत्री ने कहा कि लाइट ऑफ कर दो. ही स्विच्ड ऑफ द सब स्टेशन ऑन दैट टाइम. That happened. So what was the signal that was being deemed to be given? The signal was कि लाइट ऑफ करनी है. हमने क्या किया? लाइट के साथ हमने पंखा भी ऑफ किया, टीवी भी ऑफ किया, कुछ भाई साहब ने फ्रिज भी ऑफ किया और बाहर आ गए घर से. ये सब कुछ ऑफ करना है. We did that. और कुछ जगह सब स्टेशन वाले ने बिजली ऑफ कर दी. This also happened. So eventually you see the situation. The prediction was कि 12 गीगावाट की डिमांड वेरिएशन आएगी. उस रात को 32 गीगावाट की डिमांड वेरिएशन आई. Imagine what their prediction was. और कोई prediction कोई ऐसा नहीं कि आप और हमने बैठ के किया हो. These were predictions done by at the top most level in the country. The power grid had predicted this. कि इतना वेरिएशन आएगा, इसके लिए हमने ये व्यवस्था कर ली है. We were lucky that night. So we have to understand the system कि 22 तारीख को क्या होगा. We need to understand these things कि कब किस तरह के इवेंट्स पे हमारी डिमांड पे क्या असर पड़ता है. This we need to understand. कल अगर इंडिया पाकिस्तान का मैच होता है तो हमारी डिमांड पे क्या असर पड़ता है. Need to understand that part. So all these things, they need to be understood. The consumer needs to be understood. The demand needs to be understood. How will they behave? These are important questions that need to be solved. होने के बाद में क्या है? Nothing. You'll face blackouts. So you need to understand and control how these people will behave. So the sudden heat waves, festivals, elections, all these things, they need to be understood. कि क्या होगा? If you don't do that, you cannot operate the grid. Because now everybody is using electricity. Everybody. And very interestingly, everybody is not only consuming electricity, a large number of them are producing electricity. They have their solar rooftop. And these people, they are uncontrollable. So until and unless you study them, you observe them, and you try to control them, they'll create a riot in the system. You need to manage them. You need to manage the demand in the system. You need to understand when riots are going to happen, when any event is going to happen. You need to understand and control these people. If you do not do that, you won't be able to balance the grid. This is a domain that policymakers, regulators, government officials, they are bothered about. Studies do happen. There are certain definitions also that have come up. Definitions from, so very, very quickly I can point out it's a portfolio of measures to improve the energy system at the site of consumption. Very briefly, वो सारे measures जिससे कि मैं energy consumption side में जो uses जो है, to improve the energy system at the site of consumption side में मैं जो भी changes लाना चाह रहा हूँ, improvement लाना चाह रहा हूँ, they all constitute demand side management. People, different entities, they define it in different forms. Definitions, they can vary. आज हमें क्यों ख्याल आया कि हमें डिमांड साइड मैनेजमेंट के बारे में बात करनी है? या पहले ऐसी समस्या नहीं थी क्या? समस्या पहले भी थी, पर हम क्या करते थे? जब बिजली नहीं होती थी तो हम सब स्टेशन वालों को कहते थे भैया स्विच ऑफ कर दो. We used to go in for load shedding. That was the simple solution. किसी के दिमाग में क्यों स्मार्ट मीटर लगाएं, क्यों दिमाग लगाएं? A very easy solution. कि जब भी ग्रिड में सप्लाई नहीं होगी, you ask the substation कि भैया इस लाइन को ट्रिप कर दे. So you face cuts, electricity cuts. You all have faced it. You all still face it at times. That is a forced demand side management mechanism by which rather than bothering you कि आपको 5 से 8 में गर्मी लग रही है लगे, हमने स्विच ऑफ कर दिया. We are not bothered. We are forcing you to accept this demand side management. So this forceful or forced load shedding was prevalent, is still prevalent, but that is not demand side management. और या आपको कहा जाए कि भाई आप सोलर लगा लो, आप जितना कंज्यूम कर रहे हो प्रोड्यूस करो, that is not demand side management. That is not. So in general, if you talk to utilities, people do talk about कि ठीक है, distribution loss control, load shedding, use of renewable energy. This is not demand side management. The demand side management could be very easy form which we practice is either curtailing the uses hours कि कितनी देर आप इलेक्ट्रिसिटी यूज करते हैं वो उनको चेंज कर पाना कस्टमर्स के लिए, यूज ऑफ एफिशिएंट डिवाइसेस,
डिजिटल डिजिटल
बल्ब हमने इनकैंडेंसेंट CFL और LED बल्ब पे चलेंगे, यूज ऑफ दोज डिवाइसेस रिड्यूसेस द डिमांड, दैट इज वन मैकेनिज्म. Use of solar devices which get charged using solar, possibly that can reduce the demand. Shiftable loads कि हम कब यूज करते हैं, वॉशिंग मशीन तभी यूज करें, those type of devices, that is a very, these are the easy options that we see, though there is a wide variety of, there is a broad spectrum of issues. These are the things which people have started practicing it, but there are a spectrum of issues. We'll touch upon those. One broader issue is energy efficiency, which we have talked about. Bringing in efficient devices, lighting, cooling. We have got this. Which ACs are these? Cassette ACs.
Split AC.
This is a small building. If you have got a large building, what will you do? Will you use We'll use a central air conditioning system. Why? Why? Why do we use those? Eh?
That has a better distribution system.
It is much more efficient. If you use a centralized AC system for a large building, rather than employing so much of ACs, power consumption is significantly less, but it requires investment. So in malls, it is all centrally, you don't see all this stuff. This is cost. This is operationally it is costly. So bringing in energy efficiency on the consumer end by devising systems and components which are efficient, rather than using a split AC or a cassette AC, we use centralized AC systems. So in large buildings, you'll see centralized AC systems. Hospitals, you see centralized AC systems. Malls, large commercial establishments, we see those centralized AC systems. They permanently reduce the energy consumption. There are a lot of schemes, PAD scheme, Bachat Lamp Yojana, and a lot of schemes that the government has floated over the last 15-20 years to improve the efficiency of the devices that you are using. This is one way of managing the demand. Second is bringing in demand response, changing the pattern of demand, changing the time at which you are using electricity by way of various ways. They could be forced, they could be contracts, there could be money involved in the sense that the tariff would change. So there could be demand response is one broader segment that we touch upon. I think many of you would have heard the word demand response. Those from electrical understood this thing. Fuel substitution is another. नाम सुना होगा, सरकार कह रही है, बार-बार कह रही है, बहुत जोर-जोर से कह रही है, green hydrogen. What is this green hydrogen? Why सरकार जोर-जोर से कह रही है green hydrogen?
It emits only at water as a emission.
हाइड्रोजन बना के हम क्या कर रहे हैं? हमें को हाइड्रोजन बम बनाना है? नो. What are we doing?
You're using your cars.
Huh? We are running cars. For that we are producing hydrogen?
Fuel cells.
Yes.
No.
Or to charge fuel cells.
Fuel cells.
What will they do?
They work as a battery.
Okay.
When water is available, they convert it into hydrogen gas.
Why all this talk about green hydrogen? हाइड्रोजन बनानी है, बना लीजिए. Why green hydrogen? Why?
No hazardous. CO2 free. After burning. No CO2.
हैं?
Carbon free.
आपको हाइड्रोजन बनाना है, तो ग्रीन हाइड्रोजन क्यों बनाना है? Why?
Carbon footprints are more.
Huh?
Produce hydrogen, carbon footprints are more than the hydrogen.
हाइड्रोजन ही क्यों बनाना है फिर? ऐसी क्या फांसी है कि हम हाइड्रोजन की कार यूज करें?
It's abundant in nature. Pani is available, na, sir? Everywhere.
Producing
So it's
more
abundance.
energy. Availability of water.
But to produce hydrogen, you need a lot of electricity.
Yes.
Why waste so much of electricity to produce so less? I guess those who understand the efficiency of producing green hydrogen is too poor, minimal. कितना सारा पानी इस्तेमाल करके थोड़ा सा हाइड्रोजन बनता है. Why do this damn stuff? Why?
थोड़े से हाइड्रोजन से बहुत ज़्यादा एनर्जी.
You put up a solar power plant. 2:30 बजे वो इतना प्रोड्यूस कर रहा है कि आपका कंजम्पशन नहीं है. You don't have that consumption to utilize that generation. What do you do with that generation? That is freely available now. The times at which the solar panels are producing electricity, you are not using it. You are not able to use that electricity at that point of time. What do? You use that electricity being produced by renewables to produce hydrogen. Else, it is of no intelligence to use so much of electricity to produce hydrogen and then to use hydrogen to run a fuel cell. No. It doesn't make any sense. No efficiency, very poor efficiency. But because so much of solar panels is installed, and if you do not use them, that electricity goes waste. What do? You put up a green hydrogen plant in which you use that electricity, use water, produce hydrogen, store energy in the form of hydrogen. That is why there is so much of noise about producing green hydrogen. बाकी शोर तो नहीं हो रहा ना, grey hydrogen, brown hydrogen. We don't talk about those things. Why? Because that is not making economic sense. This one is making economic sense because electricity is now, once you have installed a नया अच्छा power plant, solar power plant, बिजली तो free की आ रही है. या तो आप इसे इस्तेमाल करें. अगर आप इस्तेमाल नहीं कर सकते हैं, तो आप waste कर रहे हैं अपने investment. So what do? You are creating a demand in the system by using that electricity. You are creating a demand which earlier did not exist. You are creating a demand which did not exist. आप जबरदस्ती बिजली को consume कर रहे हैं, so that whatever extra is getting produced, you can use it. These are not 24-hour plants. These are plants which produce solar, excess solar which is not being utilized for any reason whatsoever, and you use that to produce hydrogen. Otherwise, there is no economic sense in that. We call it power to X, P2X. Some of you may have heard that word, P2X. Lot of research, lot of funding, lot of government money is going into this. सरकार कह रही है पावर टू एक्स के अंदर आप रिसर्च करें. Lot of innovations are likely to happen. Those from mechanical engineering can possibly appreciate this. All funding is coming in this segment. हाइड्रोजन पैदा करें. हाइड्रोजन और any fuel, not natural fuel, any synthetic fuel being produced using power, we club it under the issue of under the domain of P2X. फ्यूल वैसे भी बनता है, You produce oil, petrol, all this thing. But producing synthetic fuel, it is not natural hydrogen. You are producing it synthetically. You are producing it through some process, chemical process. Producing it using those using the excess electricity is primarily a way to increase the demand or to consume the electricity which is otherwise will go waste. There's another similar thing that is coming up, which is in a very nascent stage, is what we call as load building. Why this load building? मतलब जबरदस्ती का load create करना, building a load. This is another. If you want to bring in वो जो चले गए, if you want to increase their percentage, जाने वालों की नहीं solar की, then in that case, the problem is when they come up in the morning, they नाश्ता करके सारे एक साथ आते हैं, they ramp up the system generation like anything. Morning 6, 7, 8, 9 o'clock, they ramp up the generation like anything. If you do not have a corresponding load in the system, the ramping up generator will bring instability in the system. The voltages will go up. You don't have that demand in the morning hours. 6 बजे उठ के हम क्या कर रहे हैं? कुछ नहीं कर रहे हैं. Our demand comes up at 9 o'clock, 10 o'clock. But the generation comes up prior to that. So that if you do not, those who understand power systems a bit, if you do not control it, significant ramping can lead to oscillations in the system, can lead to unstable power systems. And problem is generation comes up at 6, 7, 8, 9, 10, 11, 12, 2 o'clock, approximately 1 o'clock it peaks up. Your dependency is on these solar generators because now these are feeding the grid. You have reduced the conventional power plants, the generation. It is a thermal power plant. To bring it from 0 megawatt to 100 megawatt, you need to ramp it up slowly because the thermal stresses created in the turbine, in the boiler, they are too huge to be handled by those tubes. Those tubes will crack. So there is a ramping constraint on these guys. They don't have a Kawasaki now. They will ramp up slowly. They do not have the capacity to ramp up at the same speed at which the solar generation is ramping down. To avoid these situations, capacity is one problem, ramping is another problem in the system. मेरे पास बाइक है 150 सीसी की फाइन, बट वो रैंपिंग अप स्पीड पकड़ने में कितना टाइम लेती है वो भी तो उसकी एक कैरेक्टरिस्टिक्स है, दैट आल्सो इज रिस्ट्रिक्टेड. मेरे पास कार है 1000 सीसी की, बट वो 100 किलोमीटर पहुंचने में कितना टाइम लेती है, दैट आल्सो इज अ प्रॉब्लम. मेरी कार कैन नॉट रैंप अप एज फास्ट एज दिस solar generation goes down. The solution is I build a demand, either I generate more before this goes out. ये जब सोलर जनरेशन नीचे जाना शुरू हो उससे पहले मैं अपना जनरेशन बढ़ा लूँ, मैं अपनी स्पीड बढ़ा लूँ. एंड बट अगर मैं बढ़ा लूंगा तो there would be an excess of voltage in the system, excess of power in the system. That is not feasible. So I have to create a demand in the system, waste that generation such that when this generation goes off, I switch off that demand which I have created it artificially and allow that generator to supply the rest of the demand. So some sort of load building may also be required in the future if I want to handle this demand supply imbalance and ramping issues in the grid. जब टाइम हो जाएगा बता Whenever you feel comfortable, आपको लगे कि नहीं ज्ञान आना बंद हो गया, you let me know.
Within sir 5 to 10 minutes.
I hope it was interesting. Yes. You could understand what I was trying to deliver. There are various demand side management strategies. Energy conservation is one. Peak clipping, peak demand जब आती है, there are a variety of ways by which you manage the demand. You try to change the shape. This is more of electrical people who understand it. We try to change the shape of the load profiles. We try to shift कि washing machine सुबह की बजाय दिन में use कर लें, रात को use कर लें. We try to shift the demand. We try to shed some of the demand कि कुछ demand जो हटाई जा सकती है. Through energy efficiency, we reduce the demand, and we try to make it what we call as shimmy or flexible. कि वो demand कब मैं electric vehicle अपना charge करूँ, that flexibility be brought into the system. अब इसमें कौन करेगा, हम सब मिलके करेंगे. There are stakeholders. Utility is one stakeholder, that is the company which is providing electricity. They are one of the stakeholders. Customer is another important stakeholder. We as customers are responsible for changing the demand, provided we get that signal. Those who understand electrical, there are entities like regulators and load aggregators. There would be new entities, new players in the market, like aggregators, like Ola and Uber. What is Ola and Uber? They are aggregators. Car थोड़ी चलाते हैं. They provide services of transportation using an app. Simply run an app, aggregate the services. You as users use those services. So similar type of aggregators will come up in the power sector as well. Those who will aggregate the demand response from you. कि भैया आप में से बताओ कौन कौन अपना AC बंद करने को तैयार है. मैं आपको 5 रुपए दूंगा. ठीक है? I run an app. These guys जिसको 5 रुपए पसंद होंगे, he'll come and join the app. He will reduce the demand when I ask him to reduce the demand, or when the prices are going up. So there will be an aggregator required to aggregate not the demand, but the demand response from the system. That is the change in the demand. You need aggregators to change, aggregators to aggregate. वरना आपके 5 रुपए के पीछे system is not going to work. But हाँ, अगर आप सारे लोग मिलके 1 megawatt का change लाते हैं, 500, मतलब if you are able to make a large change in the system, their change is of value to me, for the system operator. Otherwise, it is of no value. So to bring that change, somebody has to aggregate that demand response and provide it to the grid. भैया जब वो ramping की ज़रूरत हो, I will provide the ramping through these customers by changing their demand, by paying them, and you pay me for managing that ramping. Some sort of economics, market mechanisms need to be brought in. New entities, they are coming up internationally in some of the countries. Discussions and roles of distribution system operator as an aggregator. अभी क्या है? We get a connection from the state electricity board. दमन में क्या है? Torrent Power. That is a private entity, no? That is the utility. They are supplying power. There could be, अभी आपके पास, लेकिन मोबाइल कनेक्शन लेने के लिए आपके पास यहाँ पर 2-3 सप्लायर होंगे. Only one. Only Airtel. तो Jio भी होगा, BSNL भी होगा. In a similar way, you would have multiple suppliers of electricity as well. You can get a connection from Tata, you can get a connection from Torrent, you can get a connection from Ambani, anywhere. You can do that. And new set of players would come up in the market, those who can supply electricity and also who can aggregate demand response from the system. So the industry is restructuring. I'm not going deep into it. That requires another lecture like this, possibly to get deep into this. But as a operating the system at the local level, in the local area like Daman, rather than having somebody operating from Gujarat or Surat or some far off place, you would require system operators at the local level, where they can balance the demand and supply in that geographical area itself. So distributed system operator is a likely entity that would come up. Who would participate in that demand response? Residential customers, जिनके पास controllable devices होंगे, HVAC systems, heating, ventilation and air conditioning systems, they have the potential to change their demand. मैं अगर 5 मिनट के लिए एसी बंद कर दूंगा तो आपकी जान नहीं जाएगी. So अगर 5 मिनट के लिए सिस्टम में डिमांड पीक आती है तो I can at least for 5 minutes I can switch off my ACs. So HVAC is because of the thermal inertia of the system. मैंने AC से कमरा ठंडा कर लिया तो 5 मिनट अगर लाइट चली भी जाती है, still I can sustain because the room is cool now. So because of the thermal inertia of the building, and these are, I am telling you from a civil engineering perspective, these are very important research domains that are coming up. How to understand the thermal inertia of a building, cooling, heating, ventilation, how to understand that, how to model that, and how to relate that with grid operation. This is a challenging area of research, that because buildings are the domains which would be in future would be the one of the highest electricity consumption systems. हर एक ने एसी लगा रखा है अपने घर में, और आपके घर में 4 एसी लगे हुए. आज से 5 साल पहले थे नहीं थे. हर बच्चे के कमरे में अलग एसी है, and everybody is using his own AC. So what is the demand in the housing, in the buildings will significantly increase in the future, and there is a huge potential to manage that demand, to provide demand response from that growing demand segment. Lighting, refrigeration, washing machine, dryers, heating, vehicles, all these are potential solutions, potential devices which would provide demand response into the system. On commercial side, industrial side, n number of devices would be there. Should I stop? I just briefly, I'm not going through all the slides. I'll just briefly tell you that yes, to adopt this, you require technology. One part, smart meters and all that stuff is required. Communication is required to relay all that information. Appropriate economic signals are required. Tariff design. तो जो टाइम ऑफ यूज टैरिफ है ना, दैट वुड बी रिक्वायर्ड. जैसे पहले था ना कि रात को 8 बजे के बाद एसटीडी आधी रेट की हो जाती थी. सिमिलर सॉर्ट ऑफ टैरिफ डिजाइन वुड कम अप इन पावर सेक्टर आल्सो. इट विल कम. एंड देन जो आपका माइंडसेट का जो इशू है दैट विल चेंज. हम भी तो पहले 8 बजे लग जाते थे लाइन में. आज जब मर्जी आया था फोन कर लेता. नाउ देयर इज वॉइस कॉलिंग अवेलेबल ओवर इंटरनेट. So it all depends upon the availability of technology and the economics of that technology. If it works, yes, mindsets will change. Economics is what drives all this thing. Lot of demand response programs, price based, time of use, critical peak pricing, real time pricing. Lot of those mechanisms, pricing mechanisms, they are in system, they are in place. They would be in place, possibly not right now. Automation and all that stuff. We can continue going through these slides. I've tried to touch upon the very basics of an revolution that is going to happen in electricity sector over the next 1 decade, for sure. Because now we are reaching a situation where controlling the generation beyond a certain limit is not possible. So the only option left with us is to control the demand. Any questions? I'm open to those.
अभी जो पावर कंजम्पशन का परसेंटेज है वो हाउस होल्ड के लिए कितना परसेंट और इंडस्ट्रियल कंजम्पशन कितना परसेंट रेशो?
I think I showed it in the very first slide.
परसेंटेज नहीं
Domestic is somewhere around 27%.
तो अभी जो फिर अपन टेक्नोलॉजी की बात कर रहे हैं वो 27% के लिए ही
नहीं, आपके इंडस्ट्रियल लोड में भी ऐसे बहुत सारे लोड होंगे, आपकी इंडस्ट्रीज के अंदर भी बहुत सारे लोड ऐसे होते हैं जिसको आप कंट्रोल कर सकते हैं. इनफैक्ट जो भी छोटी मोटी कंपनियां जो इनोवेशन कर रही हैं वो टारगेट इंडस्ट्री को पहले कर रही है, बिकॉज द क्वांटम ऑफ चेंज दैट यू कैन मेक इज सिग्निफिकेंटली हाई इन दैट सेगमेंट. हाउस होल्ड में तो आप एक एक डिवाइस आप घर में बेचेंगे, द इम्पैक्ट दैट इट कैन मेक इज स्मॉल. With the same device, if you put up in an industry or a commercial establishment, the change that you can make is significant. Primarily, they are targeting those industries, not the households. Those devices, there are several companies which are producing those components, small components which can control the household load. They are working in industrial segment predominantly, not in the residential side as well. Because the change, आपके कंजम्पशन में कितना चेंज आ पाएगा? 5 यूनिट 10 यूनिट, इट इज नॉट अ मेजर चेंज. आप इतना इन्वेस्टमेंट करके आप थोड़ा सा चेंज लाके क्या करेंगे? So the focus is primarily on industry as of now.
Will vehicle running with the hydrogen will replace EV?
It is very difficult to say.
Okay.
It is, in fact, truly speaking, if anybody says yes, I think it is very premature. It all depends. क्या आप 2000 के अंदर ये बता सकते थे कि सोलर पैनल इतने सस्ते हो जाएंगे? नहीं बता सकते थे. और सोलर पैनल की क्या एक टेक्नोलॉजी अवेलेबल थी? देयर वर 10 डिफरेंट टेक्नोलॉजीज अवेलेबल. सोलर पीवी सेल्स थे, आपके सोलर कुकर्स थे, आपके ट्रस्ट वो बड़े से कॉन्सेंट्रेटर्स थे, रिफ्लेक्टर्स थे. विच वन सर्वाइव्ड? ओनली वन, है ना. सो प्रिडिक्टिंग which technology will survive, it is totally a guess. Which hydrogen making systems will, whether they will survive or not, how much the cost will reduce, it all depends how new innovations happen in this segment. Depending upon the innovations, can only one take a call whether they will replace them or not. As of date, whatever perception is there, it seems electric vehicles will survive. Hydrogen is a risky game still. No clarity over that. In fact, no clarity over that. Those who claim that they'll change, no, they are making only fancy statements. It is not clear as of now.
सर दूसरा जो थॉट है, जो मतलब मैं सोचता हूँ कि हम पोल्यूशन कम करने के लिए ईवी की यूटिलाइजेशन की बात करते हैं और वो ईवीज को चार्ज करने के लिए हम थर्मल पावर को यूज.
No, if you are charging EVs using thermal power, definitely that is not a good solution. But you must understand that there are a lot of solar generation coming up in the system. And this penetration is only increasing, it is not reducing. Over a period of time, this solar generation will increase. The thing that has to be done is that EVs should charge when this is coming up. So that effectively EVs are charged from solar generation, not from thermal power plants. Yes, that perception that we are charging electric vehicles using thermal power plants, that is creating more pollution, yes. But the pollution that was coming up from vehicles, petrol vehicles, that was also too high. तो वो प्रॉब्लम क्या आती है? आप शहरों में चलाते हैं, है ना, पावर प्लांट शहर से बाहर है, so you are basically displacing the pollution out of the city. Otherwise, living in a city like Delhi has become a hell, because if everybody uses, now see the difference, if everybody in Delhi uses an electric vehicle or everybody in the Delhi uses petrol vehicle, how does it impact? The life of the people is getting impacted. So they would prefer to use electric vehicle, reduce the pollution कहीं और कर लेते हैं.
Sir, as you speak, economy will change the mindset.
Yes.
As from now, in these 2 days, we come to know about this problem. We are from mechanical branch, but many of the people don't know this problem. Can be the society have any approach? As in ancient time, people wake up in the morning, they sleep before 7 o'clock. They do many of the things in the sunlight.
It is very difficult unless and until there is an economic. There are two things. Either economy drives, because in today's generation we are driven more by money. Either the economics drives the system,
Lifestyle.
है ना? Or
Daylight saving is
we change the mindset. अब जैसे हमें पता चल गया कि इलेक्ट्रिक व्हीकल खरीदना है, जिसके अगर मैं खरीदूंगा तो इलेक्ट्रिक कार ही खरीदूंगा. दिस इज द माइंडसेट चेंज इज फोर्स्ड बाय सम measures. People change their mindset and thereafter they continue with that mindset possibly.
Can government make any policy?
I don't
like,
think that is feasible, no.
Like office time before sunset, people go early to their home.
I think the capitalists, they would not like it.
Okay.
actually
You
it
can do
was,
these things in socialist countries, you can do these things in communist countries, but if you want to grow the economy, everybody has his own perception. Usually, whatever tariff mechanisms we adopt it to balance the system. Otherwise, we don't create any other artificial load in the system in any case. The whole of the exercise is to balance the demand and supply and balance the ramping requirement in the system. These are two critical issues. कि गाड़ी की कैपेसिटी कितनी है टोटल, और दूसरा उसकी रैंपिंग की कैपेसिटी कितनी है. दो चीज़ें, ये दो चीज़ें इंपॉर्टेंट है पावर सिस्टम ऑपरेशन, पावर प्लांट ऑपरेशन के पर्सपेक्टिव से.
So aggregators are also need to identify what is the optimized condition actually after some.
It would depend upon what the market prices are. एग्रीगेटर भी क्या करेगा, जबरदस्ती खरीद के बेचेगा तो अगर उसको पैसा मिलेगा तभी तो बेचेगा ना. तो पैसा कौन देगा? जब पैसे की उसकी ज़रूरत होगी, रैंपिंग की ज़रूरत होगी, उतना पैसा मिलेगा. अगर रैंपिंग की ज़रूरत ज़्यादा है तो ऑब्वियसली ज़्यादा पैसा मिलेगा. He'll throw more money into the market. More people will be incentivized to participate. It is similar to what we face in Uber. शाम के time when the demand goes up, the tariff also of Uber also goes up. रात के टाइम और या मॉर्निंग आवर्स में, if the demand is not, discuss these things in the afternoon class also, few of those concepts. Is it fine? बोलो.
जैसे कि आपने बोला कि कॉस्ट हम इंक्रीज करेंगे पीक, जब हमारा रिक्वायरमेंट ज़्यादा होगा पीक लोड पे, तो हमारा कुछ पावर इनपुट भी होता है नेपाल साइड से, तो हम
Yes.
तो हमको पे का हमारा जो हमारा जो इनकम है देश का, तो वो ये तो कांस्टेंट टैक्स पकड़ लीजिएगा, कॉस्ट पकड़ लीजिए कांस्टेंट है, और हम लोग पे कर रहे हैं ज़्यादा, तो जीडीपी गिर सकते हैं ना अपना कॉन्ट्रीब्यूशन.
अगर हम नेपाल से नहीं खरीदेंगे तो हमें क्या करना होगा? हमें पावर प्लांट और लगाना पड़ेगा. ठीक है, पैसा लगेगा. हम नेपाल से थोड़े टाइम के लिए खरीदते और तब खरीदते हैं जब हमारी रैंपिंग की और दूसरी की रिक्वायरमेंट है. और वो चूंकि नेपाल से क्यों खरीदते हैं? नेपाल से इसलिए खरीदते हैं क्योंकि उनके पास हाइड्रो पावर प्लांट है, तो वो जब मर्जी आए तब बिजली पैदा कर सकते हैं. रैंपिंग इन द केस ऑफ हाइड्रो पावर प्लांट्स इज वेरी इजी. 3 minutes you can start a power plant. 2 to 3 minutes. Thermal power plant requires couple of hours to start. We have got a lot of those hydro power plants. So whatever our ramping requirements are, rather than building up a new plant, it is more intelligent to buy power from Nepal. It makes sense to buy power from Nepal. It is much more economical. You cannot compensate with that by putting up more power plants. No.
Sir, what is the synchronizing time for nuclear power stations, sir?
A difficult question, in fact. I'm not very sure. 1 week. I guess it takes time because synchronization time means from cold start to synchronizing it. It should take time. The reason being, a nuclear power plant has to be very stable. You cannot ramp up or ramp down a nuclear power plant. Bringing it from a very cold start, you slowly ramp up the heat up or put in more fuel. It will take time to switch it on, bring it to capacity. It will take quite some time. Exactly, I'm not very sure, but it may be taking significant. It may be taking, definitely it would take more time as compared to any other technology.
more than thermal also.
I guess 100%, because thermal power plants, the best of the thermal power plants, you can bring them, at least they'll take 4 to 6 hours. The best of thermal power plants. Best possible is 4 to 6 hours, or worst case, I think even power plants take 24 hours to come up to full. So nuclear power plants, I understand they take anything which is more than the thermal power plants. Because of you cannot afford कि आप उसमें ramping करो, you cannot afford कि आप उसमें कुछ भी imbalance करो. It has to be slowly brought up, else there are risks involved.
Sir, is there any significant role of microgrid in load balance? Nowadays, solar park of megawatt they are installing. So,
Microgrid, if we are talking about isolated microgrids, no. Isolated microgrids only handle very small portions of the demand. Isolated microgrids are only viable in areas where connecting it through the grid is not possible. Isolated microgrids are usable either in islands, one, or in military installations where you are isolated from the grid, like submarines, or isolated systems which you have to separate from the grid. Otherwise, isolated microgrids, economically, they are not that much viable. You won't see, have you seen? No. You don't see many of those. They have got limited impact on the system as of now. Very limited impact. US definitely has a larger set of microgrids because for their military installations they typically use microgrids. और जो जितना भी microgrid पे जो research हो रही है, that is primarily driven by the military. They have their systems running as microgrids, not the common rest of the people. They are connected to the grid. They want their microgrids to be reliable. So the focus is primarily on their side, not on our side. So I think that was an interesting session. I was able to ensure that most of you were not sleeping. Thank you. I think we'll meet after lunch.
yes, sir.
2. Close? Thank you.